This is the second part of the video about the features of charging lithium iron phosphate batteries on a boat. In this part, we will talk about charging multiple, series-connected cells combined into a 12-volt battery, as well as how the infrastructure affects the choice of charging scenario, as well as solutions to help solve problems such as correct balancing, synchronization and correct data transmission of a battery voltage to chargers. So, we already know how to charge a single 3.2-volt cell. Any LFP battery consists of at least 4 such cells connected in series. Moreover, the charging of cells connected in series is uneven due to different internal resistances. If you ignore this, the imbalance increases, one of the cells goes beyond the limits set in the BMS settings and the battery is forcibly turned off. This is why it is so important that the voltage of all cells should be approximately the same. Also, balancing must be carried out correctly and automatically. To do this, a proper balancer is added to the system in combination with the BMS or independently. Since batteries are subject to high load when charging on a boat, the balancer's capabilities must match the operating currents and bank capacity. In this video, we will talk about active balancers, the most effective and often used on boats. The balancer controls the distribution of current between the cells in the battery. Top balancing is the most efficient scenario for balancing the battery on a boat. The following key points that we must ensure for correct balancing. First, carry out balancing at the time of charging, corresponding to the capabilities of the balancer. For this purpose, it is correct to carry out balancing not at the main stage of bulk charging, but at the absorption stage, when the charging current drops. In this case, the duration of absorption can be selected so that the balancer has time to do its job. It is better to set the absorption duration in the charger program using parameters such as absorption duration or tail current. Second, balancing should not be carried out on flat sections of the LFP charging curve, at which point the cell capacity increases, but the voltage does not change. This often leads, on the contrary, to cell imbalance. Better to start balancing no earlier than 3.4 volts per cell. If you are charging the battery to 3.45 volts per cell, it is probably a good idea to start balancing an absorption at that same voltage of 3.45 volts per cell and 13.8 volts per battery. If the balancer operates independently of the BMS, is not controlled by the system, and its operating parameters are not adjustable, it is better to use a separate relay module to be able to adjust the start voltage. The module must be able to set the start voltage and balancer shutdown voltage. Having risen from the lower level of charging a single cell to the battery level, we encountered a necessary condition, cell balancing. We talked about how to build balancing into the charging process at the same time as absorption. Now let's go even higher, to the infrastructure level. At the infrastructure level, our main task is to ensure the correct transmission of battery voltage data to chargers, and synchronization of chargers for synchronous transition to bulk, absorption, and float charging modes simultaneously. Before discussing this in more detail, let's decide how a 3-stage charging algorithm can help us when using LFP batteries on a boat. Bulk mode is the most efficient charging. The voltage on the battery increases, and the maximum current for the scenario. The end of this mode is the beginning of the absorption mode. The absorption start voltage is normally selected in a charger program. Absorption mode. The voltage remains at a given level, and the current gradually decreases. This mode is convenient for us to run cell balancing in parallel. At a low charging current, in this mode, the balancer works more efficiently, since its capabilities are most often limited by the balancing current from 1 to 10 amperes. Since effective balancing takes place at the end of the charging cycle, it is necessary to match the charging resource to the total battery capacity to ensure that the battery is fully charged at least occasionally. Float mode. Historically, this mode was added to chargers to compensate for the self-discharge of lead-acid batteries. To charge LFP batteries, we do not need this mode, but it is usually available in the charger settings. It's a good idea to set the float mode voltage a little lower than the rest of voltage point. For example, 3.37 volts per cell or 13.48 volts per battery. There are usually several charging sources on a boat. Each of these is connected to the battery through its conductor. The conductor may differ in length and cross-section. As a result of this, we can observe a voltage drop from the charger to the battery. Most chargers measure battery voltage through their power leads. The voltage at the charger terminals may differ significantly from the actual battery voltage. For example, the charger detects that the battery voltage is 3.45 volts per cell and goes into absorption mode, but in fact, the battery has not reached it. Knowing about the losses in the wires, we can make adjustments to the charger settings. But this is not the right option. Since charging currents from alternative energy sources may be different, the losses will also be different. To solve the problem, so-called VSense devices are added to the infrastructure. Typically, a VSense device is a device connected directly to the battery. The task of the device is to measure the real voltage and transmit the value directly to the charger. Knowing the actual battery voltage, the charger adjusts the output voltage. Also, for this reason, it is a great idea to synchronize the chargers so that they switch from one charging stage to another together at the same time. For example, the simplest way to synchronize MPPT Victron solar chargers is to add a smart shunt or battery monitor BMV or smart battery sense to the system as a VSense device and then combine all devices into the Bluetooth network V smart networking. Compatibility of MPPT models can be found on the manufacturer's website. By combining everything previously discussed, we can summarize. It can be recommended to charge our 12-volt LFP battery to 3.45 volts per cell, starting balancing simultaneously with the beginning of the absorption stage. In this case, it is necessary to organize the correct transfer of data about the true battery voltage to chargers and also, if possible, synchronize charging sources for simultaneous transition between charging modes. Thanks for watching and goodbye.